Group 1 that consists of Hao and Min, Lam Chehui, Nurul Fatin Izzati and Siti Faris Najwa will be presenting the design of 5G microstrip patch antenna, and we are going straight to the introduction.
Hi and Assalamualaikum. My name is Nurul Fatih Izzati binti Abdul Rashid. For introduction, according to the fast advancements of technology that happen right now, the request to have an antenna design that has further developed their characteristic is necessary. For example, like their antenna size, bandwidth, transmission capacity, gain, and high information rate. To resolve this issue, we will design the microstrip patch antenna for 5G application will be introduced in this project. To support the idea, the substrate used is Rogers RT5880 with the electric constant 2.2. There are many substrates out there, but why we choose this Rogers, this is because it can provide the best wave and have an ultra high frequency due to their low dielectric loss and low dispersion. And at the end of this project, we will provide a high data rate, large bandwidth, and high capacity, as well as our main objective to achieve the 5G that will be commercialized soon. And for problem statement, with 4G network that currently used still have a lags and unable to support some criteria which affect the user satisfaction. This is because previous and current network have their own disabilities which is not in line with the latest advance of technology. So by introducing the idea of this project, will become one-stop solution for 5G that will full with benefits and advantage either to user, society, country, and also worldwide.
Hi, my name is Hao Ming. I'm going to present methodology of our project. Before starting the project, initial setting for new project. A new template is created for new project. Microwave and RF or optical is selected with antenna region. Next, select planner for project template and time domain as recommended solver for planner workflow. Default setting a unit. A minimum frequency of 20 GHz and a maximum frequency of 40 GHz are set for project template. Lastly, make sure all choice and settings are correct and name the template. Now, start to design a 5G microstrip path antenna. The perspective view is set as front and maximize the view to the default size. The length, width, or height of ground plane substrate path and feed line are set. Next, select the brick under modeling to set the parameter and double-click at the working plane, then press enter. Name the brick as ground plane. Set the parameter of X, Y, and Z and select poor copper as material. The design of the ground plane is shown as figure. Then repeat the step to set the parameter and material for substrate and path. The design of the brick name, substrate, and path is shown as figure. Select pitch edge center under pitch point and locate E as the figure. Align WCS at the same location. Repeat again the step to set the parameter and material for feed line and show the design. The error of the setting can be collected from the history list. Add balloon is used to add the path with feed line and show the design. Select pitch face under pitch and double click as the location as figure. Select wave guide plot under simulation to set the position. The design is done and start the simulation. Thank you.
Hi, I am Lam Chi-Hui. Today, I would like to explain about the results and findings. Table 3.1 tabulates the respective lengths for the parameters used for the design of the 5G microstrip patch antenna. HS, LP, WP, and WF are the crucial primary parameters that determine the features of the antenna. Meanwhile, the LG, WG, HG, LS, WS, and LF are the secondary parameters that determine the operating frequency range of the antenna. These three formulas are used to calculate the relative length of the patch, effective dielectric constant, and width of patch. C is the speed of light. F0 is the resonance frequency with 28 GHz, and H is the height of substrate. This figure illustrates the structure of the 5G microstrip patch antenna. These figures illustrate the S parameters of the 5G microstrip patch antenna. The resonance frequency achieved is located at 27 GHz with negative 19 dB. Meanwhile, the bandwidth below negative 10 dB is located between 25.85 GHz and 28.21 GHz until negative 19 dB. These figures illustrate the VSWR of the 5G microstrip patch antenna. The VSWR between 25.85 GHz and 28.21 GHz are 1.92 and 1.26 respectively. These figures illustrate the power of the 5G microstrip patch antenna. At resonance frequency 27 GHz, it has the maximum power accepted, 0.49 watt, and power radiated, 0.45 watt, as well as the minimum power outgoing all ports, 0.006 watt, while the power simulated is 0.5 watt. The power radiated and power accepted are in phase, while the power outgoing all ports are completely out of phase for the entire system. These figures illustrate the far-field results of the 5G microstrip patch antenna. At frequency 27.36 GHz, the antenna achieved realized gain of 7.25 dBi. Meanwhile, the realized gain achieved by the antenna at resonance frequency 27 GHz is about the highest, with value 7.13 dBi. The axial ratio achieved is a constant with value 40. The front-to-back ratio achieved is 14.12. The HPPW achieved is negative 0.37 radian or equivalent to negative 21.76 degree. The side loop level achieved is a constant with negative 1.23 E plus 28 dB. The main loop direction is keep unchanged before 34.7 GHz. The total efficiency achieved is 0.91. Thank you.
My name is Siti Fairuz binti Aziz, and we can conclude that in this project, a microstrip patch antenna is designed for 5G application, where the relative antenna has ground plane and patch size as mentioned. So the output resonant frequency achieved was 27 GHz as mentioned earlier in our results and findings. So it has compliant resonant frequency and bandwidth, low VSWR and high and in phase power accepted and power radiated, as well as the lower power outgoing all ports that is completely out of phase. Besides, the visual lobe of the frequency that gained in the application shows that it fits the 5G range and requirements as well. Hence, the design was quite successful. Moving to the recommendations, that the targeted resonant frequency was initially 28 GHz, but the achieved one was 27 GHz. It is quite obvious that the theoretical value is distinct with the achieved one, even though both of the frequency are covered under the 5G range. For a better enhancement, that the LG, WG, HG, the LS, WS, and LF should be adjusted to achieve the actual resonance frequency as